notice of change. For a lot of us in the CM services sector, which I fall into in Australia, a lot of our day is taking up with collecting data, analysing data, and what do we look for when we're going through reams and reams of data on hours on end? Is a lot of the time we're looking for change, looking at change in amplitudes, change in patterns. If we see certain changes, we look elsewhere for what else has changed, whether the motor currents change. So we're looking for all this information, and it's really good to hear that at some of the other topics that were shared with today, that I've heard so much conversation around data as information, because it's really what I wanted you guys to continue thinking about when you approach your programs. What are we doing? So for the average CM consultant, who here is directly involved with data collection, analysis and reporting? Who here today does mostly that? Just get an idea. Okay, who manages programs that may occur on their plant? So there's a variation in who works for a service company who does that as a first hands up. No one? No, a couple. And who does it in-house at existing plants? Okay, so there's a good range. So it's fair to say a lot of us are here because we're directly or very closely involved with condition monitoring. Now, the reason that I thought to put up this image here was a change barometer, because a lot of the time what we're doing is, are we not, we're gauging equipment, we're gauging and measuring, and we're making decisions on what we measure. Something, a term that I like to use with all of our guys that I work with back at home and with some of our clientele, is that if we don't measure things, how can we manage things? And I think in any aspect of life that you're in, you can apply that, but especially within condition monitoring and especially within reliability programs, if we're not actually measuring things properly, how can we be managing things? And so I just want to have you guys thinking about that today. There we go. So a little bit of a background case study, and it's a very quick overview. There's not a lot of detail in this. I can talk to you a bit more about it later, but I just wanted to move through quickly because I want you to pick up on aspects that may enhance your program or enhance your thinking of how you approach condition monitoring, because we're all in this game because we either have a passion for it, we enjoy it, we find it interesting, and for me, in the service industry, I want to see more and more people have an understanding that condition monitoring is something that works well. And so if we want to project this image into our industry and make it culture that condition monitoring is really a part of integrated into maintenance, not something separate that's done by a company that comes along or the guy who's internally just interested in doing the VA. We want to see that it's more than that. So a little bit about this background is I have a Hanson 760 kilowatt gearbox. It's in a reasonably large coal mine in Australia. It's a triple drive drift conveyor. So there's actually 3 of these transmissions. This transmission itself is, sorry about the image, might be a bit distorted just as it fits in, but that's one of the gearboxes there. The coupling goes through into a large pulley. It's about a 3 metre diameter pulley. On the other side here, if you can imagine, sorry guys, for those over there, there's another transmission that's exactly the same, and then just in by of that is another transmission, all the same 760 kilowatt drives, and we monitor these things and have done for the last 8 years. But a little bit about the gearbox itself, and the reason that I put this drawing up is because depending on where you're at with your capability of condition monitoring or vibration analysis in particular, and how much understanding that you have of machinery, that's extremely important. I think it was touched on again a couple of times today that to have a great success in what we're doing with our vibration programs is having a unique understanding about our equipment and the equipment that we're working on. So for the average analyst here, we obviously see there's an input shaft here. The gear is one piece with this shaft. We move on to a second shaft. We have a gear, smaller pinion there, one piece all the way through. This gear here is pressed and keyed, and as you can see, all the way through the gearbox. So we have intimate knowledge of the fits and tolerances. We need to know all the bearing details so we can work out our fault frequencies that are associated. We need to understand our gear train, whether it's straight cut, helical cut. We need to understand the teeth numbers. So we can actually build an appropriate analysis parameter set, if you like, to come up with good data. Again, we're measuring things, so we want to measure things properly so we can table information when we have a problem. A lot of the time when we're tabling information, sometimes CM consultants I come across haven't provided enough information to have the leverage that they need with the decisions that they want to make. We'll talk a bit more about that later. So good understanding of our machinery is paramount for programs to work well. And I assume all you guys are super experienced and you know all that, so bear in mind that this might be new for some people and it might be well and truly old news for most of you guys here. So what was the process of events and evidence that led up to a problem with this transmission? Well, I'll give you some advancement on where we're going to go with this. This was a transmission that regularly gets surveyed once a month, unless there's any particular issues or anomalies that have shown up in the years, and we obviously shorten those frequencies up. But in the process of this, this transmission getting done regularly, there was a significant change in the data which we're about to look at. And that data ended up identifying a problem which was a major component failure within the gearbox. But at first, what you're going to see now is the fact that it wasn't so much an easy decision. So the first variation that we had, and these aren't ranked, like we didn't see anything in the VA first or anything like that. This is just how the script is rolled out. In the month of December, only just last year, one of our guys reported and noted that the gear mesh frequency in both the waveform data and FFT spectral data showed significant amplitude increase. Because there was our first change. Remember, we're talking about measuring and managing. So there was a first change and there was a variation there that was quite considerable. Let's have a bit of a closer look. Sorry, I just have to come out a little bit. So obviously, see here, I've made it nice and simple. I haven't put heaps of data in so we could actually see what was happening a little bit. We've got our just let's take it on the second shaft, around 830 RPM. So we can clearly see in history, this is going back to October, and that was November, and this is December, the month where we saw a significant change. We're always seeing historically in this gearbox, we can always see the second shaft gear mesh frequency quite clearly, even velocity, and to a lesser extent, the input gear mesh frequency. Just prior to this, and that's data that I haven't got in there, my apologies, we saw a change with the side banding that was occurring at the input gear mesh frequency. So we've seen a change in the side banding, which was actually half times. I think that'd be about 7 hertz. Because this speed is, 830, so that'd be about 14, maybe 13.8 hertz is the frequency for that second shaft. So having all the data and all the information that we need on board to make decisions and make accurate decisions is pretty straightforward for people who've been doing it a while, but maybe someone who's newer into the industry, you're trying to think, how do I understand more about what's happening in this gearbox? How do I understand whether that's load related? What if that's just load? What if it's nothing else? These are massive transmissions. You get a data change like that, you don't ring up and say to the colliery, look, you need to pull that transmission out. We've had a doubling of the amplitude in a couple of the gear mesh frequencies on both the input and the second stage. We need some more information than that. Just go a little bit further. Obviously, we saw some impacting even in our waveform at quite significant levels. If you were to audibly go into this, what you call drive house, you couldn't hear any difference to the gearbox. There was no one suspected anything. Even our analyst said he goes there all the time, and audibly there was no change, but obviously in the data there was change. There was significant change. These are the previous months, just prior. That would have been October, November. Some certainly have been a step change in December. Something's actually occurred. At this stage, we don't know what. We're obviously reading the results of what's occurred, but we actually don't know the detail yet. Let's go a little bit further. So obviously, we wanted to have a look at the bearing associated with that second shaft. No particular fault frequencies indicated. I just chucked that up in there just so you can see how you would overlay something. Again, some simple stuff, but I'm amazed at sometimes some audits that we get involved with in Australia, obviously. Some things that are so simple don't get done properly and don't get done well. I was only talking to a guy a couple of months ago, helping with some analysis, and he'd been working on a site for 5 years, a guy who worked internally in industry. And when looking at a problem that he couldn't understand, when looking at his data, I said, mate, where's all the, what's the information that you have on these transmissions? Oh, I don't have any. The OEM, it never really gives us that information. And dug a little bit deeper, and we talked a little bit longer, and then he sort of said, oh, about 12 months ago, the transmission came out and was overhauled, and that's why I'm really worried about. We've seen this change about 12 months down the track, and I wonder whether they've done something wrong. And I said, well, you've told me you've been here for 5 years. You still don't understand what's actually in the transmission. You've got no idea of the bearings that are on each shaft to calculate fault frequencies. You're not sure of the gear teeth numbers or the gear train, but yet the gearbox was overhauled. Why weren't you there? Why weren't you looking? So an encouragement for you guys out there, if there's people out here that have got very large programs on and they sort of just get flat out just in doing programs and producing reports and information about machinery, spend some time to make sure you find out everything about your machinery that you're dealing with. Find all the information. Don't ever feel that you can't push and find out the detail that you need to make good decisions. Because when tabling good decisions to management, you need that information. You need that information to support your findings, even to support your own understanding of what you're saying. A second variation was our thermal imaging. We conduct regular mechanical thermal imaging on these drives throughout the coal mine, and we do it at most. And some good information came out of this as well. Over the years, I've been told that, look, mechanical thermal imaging, it's no real value, but there's always value in all the disciplines that we have. And here this week, we've got various vendors that sell excellent equipment. All those pieces of equipment help, and they're all tools, and they complement one another to give us good evaluations, to give us good understanding of what's going on. So what did we see in that same month? It was reported and noted that one bearing position on the second shaft had seen an increase in the body temperature, and it was about 30 or 40%, with a concentrated temperature around the bearing position. Let's have a bit of a closer look. This first image is not the image that has a problem. The temperature that we're normally seeing around that second shaft there is normal. We take these images every month, and they're logged and kept, and for reference purposes as well. And also there's another data run sheet, but it's pretty normal that 82 degrees was that bearing position. Is pretty regular, fairly stable, never really changes. But on the other side, the side of the problem, let's go to the next slide. So we had a good reference there of what we normally see for temperature. Doesn't look much, but we've seen here we've popped up to around 112 degrees. So there's been a significant increase if you were to talk percentages. But again, large transmission, big drives, no one seems to worry about this sort of temperature in itself. But it's the increase that was a concern. And what was quite odd was on one side, I think I can go back.
You want to go back one?
There we go. Remember, on one side we have 82, and that was consistent. This is the same shaft. But on the opposite side shaft, we go to, just had it, there we go, 112. What's going on? Why a change there? Why a change in that bearing position? Now, let's think just a little bit deeper what's actually happening there. To get a fairly simple equation that I could sort of think of for thermal energy, is probably, what would that be? Friction load and velocity. And so we know that in a transmission, that second shaft, that the velocity won't be changing at all. It's fairly constant, other than when it slows down and it starts back up. But it's constant. So the friction load has changed that bearing position for some reason. Doesn't mean the bearing's worn out. That doesn't give you an indication. But the load has changed. Our first concerns was, had there been something moving in that shaft, in the sense that had that whole assembly slightly moved off and that bearing might have been in a little bit more preload. That was the first assumption. Something that was running around in our heads anyway. Let's go to the next slide. Third variation, oil analysis. Again, another great tool that we can use, and the review of the oil analysis data at that time indicates an increase about 3 times, sounds pretty dramatic, in the ICP, or the spectral results, parts per million. ICP is inductive coupled plasma. I think that's just a particular method that's used. And the PQ index. I'm not sure if you know the difference between the two. ICP or spectral results for parts per million will always be particles probably well below 10 microns, probably about 8 microns and below, and all the equipment that we use is. And the PQ index is normally indicative of particle sizing about 20 microns and up. So let's have a look. We've seen smaller particles increase, we've seen larger particles also increase, and that started in November, actually just prior to where we saw a significant change in the data, in the vibration data that is. So again, all this information, all these measuring tools help start to form a decision going forward. It's all important. And in December again, it increased one more step change. Let's have a look. I've just grabbed a couple of older points rather than have a whole heap in there and then change the graph. But even right back to February in that year, through to I grabbed July for you guys, and then October when we have that other vibration data, chucked in a point there. So reasonably stable in all results. We actually take 2 positions on these transmissions because historically we've found there's just a bit of consistency at one end of the box to the other. They're quite physically large. And as soon as we get into November, we start to see a step change. I think that would be the iron. So there's the ICP results starting to accelerate north. Just lagging behind that, the larger particles, so smaller particles getting produced, larger particles starting to get reduced, and look at that, they even accelerate at pretty much the same rate. So we've seen quite a step change. We've seen a change in the vibration data, in the gear mesh frequencies that is. We've got side banding at that shaft speed and half of that shaft speed, so it's implied there's some looseness there. Something's going on. We've got material being created in the oil. We've got an odd temperature increase on just one side of that shaft position. That was a bit of an odd one. That was a bit different. That was causing us to scratch our heads. So the concerns that were raised, our first concern is that, well, maybe the geometry or the gear condition has to have changed. I mean, this is basic textbook stuff. You learn this in level 1, level 2. You know, we've had an increase in gear mesh frequency, so something must be changing to the gear condition, or something must be changed to the geometry of the addendum and de-addendum as the gears interface. You're getting that sort of change in amplitude in these side bandings. Our second concern was the friction that's increased in that bearing position. That was a little bit trickier, a little bit less textbook, but we know to obviously increase the body temperature, we've obviously increased friction there somehow. What's going on there? Has the preload on that bearing changed? Has the bearing shifted in its position somehow? And our last concern was obviously we could table the fact that the gear or shaft material is indicated within the oil compartment. There's nothing else it can be. Gearboxes are fairly simple. So these 3 concerns are raised. And what's good about having a range of concerns like this when you're actually about to move into making a decision for your clients is that we've got data, we've got information, and we've mentioned that a lot today. You know, we've got history, we've got accurate trending. I mean, all these things are basic tools, but you'd be amazed at how often they're overlooked. Or trending's pushed out too far. We can only get to equipment every 3 months. There's value in all these things being done regularly. There's value in all these things being measured regularly. So if we're measuring these things, we can be managing the outcomes a bit more. Let's go to the next slide. So the next point to move was really, let's go to a visual examination. There was an OEM getting involved now because there's some little bit of information I haven't told you, but back in 2009, this gearbox was overhauled. We'd picked up gear degradation actually in this gearbox, in this position, once more, and we've got a reoccurring problem. It all sounds pretty straightforward. So let's get the OEM up and we get our site representative there, and we're going to not pull the gearbox apart, but just have an access position to look inside and point and show what we've got wrong with it. Too easy. So what we thought we'd do is internal inspection, have a look at the gear profile, assessment of the shaft position if we could do that. We're trying to visualise that. We're going to do some backlash readings as well. We had all that gear, and due to the size of the unit, we could pull a side plate off the bearing cap and do a limited, or if possible, inspection of that 22322 bearing, about 110mm shaft that would fit onto. So we had all the equipment. We had all the data, our vibration data, our thermal data, our oil data, all these concerns we're tabling, and now we're going to stick our head in and see what we can find. Oops. So when we first start looking at the bearing, it's one good thing to have a full understanding and appreciation of the clearance in the bearing. This image doesn't talk about that, but I just chuck that in just so you can start thinking through. We assume internal clearance on this bearing would probably be 0.11 to 0.14. That was actually assessed, and we had a look at that while we were there. And that's just an image there to give you an idea that the access that we did have. We had the opportunity to put our very fine little endoscope that has a 1mm end just in here, have a look around inside. We didn't feel that there was going to be any bearing anomalies occurring because the data wasn't telling us that, but you know, doesn't matter how old you are and how long you've been in things, you don't just make assumptions. It's good to double check. We checked all this out, everything looked fine with the bearing. Moving along. I think this might need a battery. I'm having the same problem that Chris had, I'm sorry. Now, please note that this shaft has moved. We physically moved that shaft. It wasn't found like that. So if you're looking at that and think, crikey, what's going on? The bearing's sticking out. You're dead right, but we did that. That wasn't like that. So yeah, look, we had a look around in the gearbox, had a look at all the teeth, did some backlash checks that we were able to do physically. Not the sort that you would do in a workshop situation, but we needed to get to the bottom of this. Everything looked fine. Hang on. The data's not saying that. You know, do we throw that out? Do we stop trusting the data that we're getting from our vibration sensors? Do we stop trusting the data that we're getting from our oil analysis, from our thermal imaging? You know, this is all telling us is change. We're measuring things right. We're doing things right. What's going on here? We're starting to walk away with egg on our faces. An OEM's been brought up for a couple of hours. They've had a downtime window, which is we've asked to extend, and everything looks fine. What's happening? Who's ever been there in this sort of situation where you really start to second guess? And at least you're honest. Thanks, mate. No, it was getting a bit concerning. So what did we find? All associated gears appeared to be in satisfactory condition. The shaft and gear position was confirmed to be satisfactory. Inspection of the bearing, although limited, I admit, but it appeared to be in good order. So a decision's needed. What are we going to do? We're going to continue in this vein and just do some more regular testing and continue on, maybe at a more frequent interval, to see if there's any more changes occurring. That's a really good suggestion. We've thought through that, and you guys are probably all thinking that already. But trouble is that this happened to be just a week outside of Christmas, and there was a week's window of opportunity to change this transmission out if there was a problem. And the pressure was on to make a decision if that was the window, because in these coal mines in Australia, they budget 97% availability. Someone here was speaking in a presentation, they mentioned that they were impressed with having 96% availability, and that is good. But these guys who aren't engineers and that aren't mechanical, their production, they actually budget that this thing's going to be going 90% of the time. So there was a fair bit of pressure on us as a service provider to provide the right answers, to provide the right direction, and no different for you guys, whether you're in a service company or whether you work internally at a company in-house. At some stage, a decision has to be made, and what does it require to make the right decision? So all associated data across each technology was indicating significant changes. Downtime for that pit was about 100,000 per hour. So I didn't want to get to, say, leave it in just on a whim, what the visual examination brought to us, and then find out that in 2 or 3 weeks' time, something is let go because another gearbox had to be sourced. The OEM, and that's the overhauler that did the overhaul back in 2009, which is really not that long a time frame for a transmission. Originally, these transmissions would have been there for 40 years. The OEM was saying it's not an issue. These guys are dills. We'd never met them before. Anyhow, I didn't think I was a dill. I didn't think the guy doing the works for us was a dill, but I was starting to second guess what was going on. But we've been around long enough to know that the data doesn't lie, the information is correct, and something's going on that we can't see. Let's move right along. So we get to the point where our relationship with our client, the underground mine, has been so good over the last 10 years, or 8 years, sorry, and decisions that have come out of condition monitoring and asset reliability that we've been involved with. It's been so positive for them. They felt to side with us rather than the OEM and organised the replacement for that gearbox to be done within the week and fit into a program that when they had a down period. So what was revealed on inspection, I'm sure if you've been involved in CM, if you've been involved in vibration analysis, at some stage you've all made a decision to pull a piece of equipment out, have you not? If not, you must be going to a very reliable plant. So I'm assuming you all probably made a decision to pull something out, pull it apart, and what's the heart rate like when you're going to a workshop or you're walking down there and someone says, you need to come and have a look at this? You think, oh great, they haven't told me, they're setting me up, what is it? So what is revealed on inspection, as you can imagine, our heart rate was up. We were confident that there was a problem, although we were concerned about whether we had made the right call. And there's two ways to look at that. But so anyhow, let's have a look. I suppose you're all waiting. I think this needs batteries. Can you roll that on, Simon?
Yep.
Thanks.
If I can.
No. Drum roll. Tension's building. That's right. This doesn't work.
Okay, I'll take it out of the power point if I can.
Oh, there we go. I have to apologise that there are some photos that are a lot better than these, but these was a bit of a rush job for me, so they're not very good photos. Upon inspection, the top cover gets pulled off, and we weren't involved. We drove down to Sydney, it's about 2 hours away, and everyone was saying, yes, we can't see anything wrong with the gear train, but we knew that anyway because we did that when we were on site. Everything was getting pulled apart, and as they were lifting up and craning up the second shaft and turning it over to sit on the bench, bang, the shaft had a full section crack. The only thing that was supporting it was underneath the gear and the keyway. So that's obviously one piece through there, and the rest of it would be up here somewhere. So I was a lot more relieved when we got there and we saw that this was the outcome, because the data was telling us everything correctly. And even upon a visual examination and walking away feeling less confident about what the problem was occurring, that we felt that something was occurring in that second shaft. What I haven't told you, that our suggestions to them was the fact that there could be slipping of that gear, the larger gear, which is about 41 teeth, on that shaft. But at the same time, I didn't feel that I wanted to go out in a limb. I just said, look, I feel that there's something going on in the interaction between that gear train and that shaft due to the data that we collected, the information that we received. But I said that I was a little bit unsure, but while we saw the increase in friction on that particular bearing on the one side, but when you actually see that, what happened, that was starting to walk out. So when you have that transmission on that second shaft, you have a bearing here and a bearing here. The bearing that was increasing in temperature where the friction was increasing, it was actually that shaft starting to walk out, wanting to walk out of underneath the gear. Let's go to the next slide. I'll try it here, Simon, see if that works again. No, I'll have to get you to... So you can see the fretting that's been occurring in there. Without going into too much detail, that cracking has been occurring over a long period of time, starting in the keyway edge. Data was telling us everything right. Just because we couldn't see that doesn't mean there wasn't something going wrong. So this created a much larger investigation, which we're still in the process of, that we're involved with for our client and with the OEM. But it appears that there hadn't been adequate fit of that gear on the shaft. Been working in the keyway, cracking so low, low stress, high cycle fatigue cracking is starting to occur. Now, the other end of the scale is that post this other transmission going in, we have done some strain gauging on the output shaft, and then to calculate with obviously understanding the geometry of the output shaft and the keyways and positions, and using FEA modelling to get an idea on the loads that are shared between the three drives. And drive number one, this drive here, which had a failure, wasn't so much a failure, it was the gearbox was failing, degrading. Back just before 09 that we asked them to pull it out, we found out that there's been a 30% increase in load. Now the load, sorry, I'll just rephrase that. This gearbox is taking 30% more load than the other three. It's doing the lion's share of the work. And in fact, when collecting some data on having the drives accelerate, you could see with the strain gauging that it was a matter of milliseconds, admittedly, but this gearbox actually advances first and therefore drags and speeds up the other box, which, because it's directly bolted, so they synchronise their speed ultimately, but you're still having one box do all the work. Pulling in could have been part of, not saying that the fitment was incorrect, but just with the added contribution of this gearbox having more load and starts as well, it's probably contributed to the failure. That's in very brief form. It worked. So what did we learn? Because I'm conscious of time, I wanted to speed through for you guys. The data was indicating everything correctly, giving good information. This is something that right at the beginning, I suppose I just wanted to ask all of you guys that are involved in CM type programs, whether you're hands-on and do it or whether you manage it, are you assured that all the data that you're collecting is good? If it's good data and you're trending things properly, it's something you can trust. If you're collecting rubbish, obviously it's not good data, it's not good evidence. Because when you go before tabling a problem, the more information, the more good data that we have, the more stuff that we're measuring, it gives us confidence in our decision-making process. With that gearbox, the information that we had, we knew was good, and we had overlapping of different methodologies. So all the data in point 2, all data methods were complementing. That was giving us that sense of confidence that there is a problem within this transmission, within this drive, even though we couldn't see it. Also too, the importance, I wanted you to think about the importance of accurate trending. Accurate trending, you know, there's lots of facets, and some have been mentioned today actually, which can upset trending. You need to look at a consistent approach, whether you've got remote accelerometers on machines, whether you've got portable analyzers, ensuring that the magnet size is the same, so your mechanical filtering at the low end is not different, like accelerometers, like sensitivity, at least in range. There's lots of little factors that can really influence good trending. And if you don't have remote accelerometers, set up target points. Like if you've got a lot of data collection going on, and if you've got multiple people maybe taking data on those routes, ensure you've got processes in place where you're intentional to get accurate trending. So remember, good data comes through good trending. All our data was complementing. Fourthly, wouldn't it have been disastrous just to trust our visual inspection? Wouldn't have been disastrous. We could have said, yeah guys, admittedly that everything looks fine. There's no wear on the gear teeth. The backlash seems normal. Bearings have certainly no abnormal defects of any severity. And we could have just boxed it up and said, let it run. Imagine if that would have been happening. That could have been disastrous, the outcome of that transmission falling apart and that pit being down at $100,000 an hour. I think I'd take annual leave and go missing. So last point, and it's probably something I wanted to stress about this topic, taking notice of change. And that's, don't expect only conventional failure modes to occur in your machinery. Quite often with CM programs, we see lots of generic failure type modes, whether it comes from misalignment, whether it comes from resonance issues, whether it comes from bearing defects or lubrication anomalies. These are all conventional type of failures, but a through section crack in a large shaft, and it's probably, by that time it goes through the gear, it's probably only a 200mm shaft. Not something you would expect. Now, we put in place ultrasonics on the other gearbox and have found a crack that's already 50% through the other shaft on the other transmission. That too was overhauled in 2009 by a particular company. So bad practices and bad results. So for guys in the world of condition monitoring, don't just assume anything. Don't just assume things are built well. Don't just assume just because it's gone to the OEM for overhaul that everything's fine. Be involved right from the ground level. That's what a good program is. A program is not just how often I do VA data collection or thermal imaging or oil sampling. A part of that system as a whole working well is you guys being intimate with the machinery and right from the build. That's where reliability starts, at the build. Coming along and doing vibration analysis is a secondary thing. It doesn't make the machine more reliable. All we're doing is predicting and measuring, but reliability starts at the build. So guys, if you learn anything from today, if you sort of want to reinforce, if I wanted to reinforce anything today, is that ensure that you're getting good information from your data. And good information is not just collecting data well, but having the tools to analyse properly, knowing your machines, knowing all the bearing details, know everything about the machine, lubrication. So that's all good information. All data methods can be complementing. You don't let anyone tell you that one method alone is a standout. That may be true in some circumstances, but when you're at an investigative level, use all sorts of information that you can get. Go across all methods. So the importance of accurate trending. If you haven't got any accurate trending happening in your plant, it's really something you need to think about, and I'm sure there's plenty of people here that you can talk to and some of the training institutions that you talk to that can help you with that, help you set up some good parameter sets, help you set up some good trending processes. Very important information. And don't always just expect conventional failure modes to occur. Sometimes you've got to think outside of the square and assume nothing. That's it, guys. I hope you have a great rest of the evening, and I just thank the VANZ committee for the opportunity to share this afternoon this little topic, and I've really enjoyed our stay. Thanks very much.
Good time.
The question there for you.
Oh, sorry, mate. Yeah.
Did you consider using acoustic emission sensors testing in angular domain? You could actually sort out the shaft, which is actually on duty for this fracture. I mean, if you just have a couple of shafts and you have all the magic numbers of the gearbox in, and if you do the analysis, you could basically listen to the fracturing using the acoustic emission sensors. As you mentioned, with strain gauging and only these short impulses actually happening, you can pinpoint it even if you have a gearbox with many shafts in there. And even from the outside, this can be done for identification purposes.
Yes.
It's just going between 500 kilohertz and 2.5 megahertz, and for the envelope detection.
That's very good.
So that's another possibility actually to back up all the other information you have when you want to find out which shaft is actually the guy in charge.
Certainly, yeah. That I haven't had a lot of experience with that, to be honest. We only had a day leeway to make a decision. Just the timing of events was just so shortened. There could have been some other methods that we could have implied, but yeah, so that's a really good point though. Yeah. Appreciate that, yeah.
Some more
I've
questions?
seen very similar sort of failure. It was actually on the, I don't know whether I need that, on the output shaft, and they were changing a coupling, and there were big 45-degree cracks. So we've started as a standard process to ultrasonic the shafts now, looking for cracks. And when you had the side plate off, if you'd banged an ultrasonic transducer up there, you would have had all the info you needed. So the VA boys need to look just outside their little box, and it's not just vibe, it's lube, it's ultrasonics and crack detection, all sorts of things.
Yeah, well, there's a sense that in all fairness that you know, it's hard as a service company to be saying that every transmission you do, you need to be doing ultrasonics on it reasonably regularly on shafts, because have through-section cracking. So there's always you've got to give equipment a benefit of the doubt that there's inherent reliability designed into equipment. Where the issue was here was the rebuild, and it obviously wasn't till a couple of years later that, you know, that fracturing would have taken, you know, could have been 12 months. So hence, straight away when we saw that, we've got to check the other transmission, and sure enough, we actually found cracking on the input shaft, as well as the second shaft on number 2 transmission. So yeah, that was a good find as well. And I suppose learnt out of this that, and something, it's all part of learning, that maybe, you know, if you're dealing with an older plant, that's certainly something you can have in the program, even if it's 6 monthly or 12 monthly, to be doing something like that on some critical shafts. Yeah.
Obviously, it's easy for us to look and ask these questions because you've seen the result.
Yeah.
But one of the things that I was interested in is once you saw the failure and what have you, did you go back over your data and did you learn anything that was in your data that you maybe had missed? One thing that I've noticed when you had one of the spectra up, and I thought what we were going to hear is that you had a cracked tooth or something, because you had a marker sitting on the 1 times. There was a 1 times knock, and I'm not sure what shaft it was because I'm not sure what I was looking at.
No, it was the second shaft, yeah.
Yeah, so you had a 1 times knock in that shaft anyway. You had it marked on your spectra. Is that something that you learnt afterwards in hindsight?
No, look, we were fairly confident that there was a problem with we felt, to be really honest, at that time, interface between that gear where it was pressed onto the shaft. We shared with our client that we haven't got complete confidence, that we need to do some other testing if we wanted to actually really define, but because we had 1 day to make that decision before the maintenance day started and get that transmission out, we were pressured for time. It was at the thin end of the wedge. So in the end, there could have been some other testing that we would have done if we had more breathing space. But yeah, certainly it was quite evident that there was a problem in there and it was showing up. But I didn't expect that we'd find that, to be really honest. I didn't expect that we'd find a complete section crack through that shaft, if shafts like that. So it's a fairly big shaft. But yeah, no, it's the data was telling us pretty much everything we needed to know to make a right decision. We could have had more information, more data, and some other testing that might have defined. I would have jumped into doing a UT scan on that shaft as the next thing. That was our plan, because we felt that we were concerned about the gear moving on that shaft in the keyway and inducing cracking. But we didn't expect it to be that level of cracking. That was quite surprising. But because of time frame, yeah, we made the decision to pull it out.
Okay, we've got time for one more question. Was there one more question?
I've got a question. I was curious, you with the oil analysis, you were seeing, the iron go up and the PQ index. Where do you think that was coming from? And were you able to actually look at the oil samples, to look at the particles, to get a clue?
Yes, it was, Jason, it's coming from the shaft itself. It was when the shaft, didn't have another photo there for you guys, but it was the shaft, a lot of reasonable amount of material to come out. And that's where there was no There's no material loss of any evidence visually on the gear teeth or the interaction between them. They were still...
Under a microscope, the particles didn't give a telltale sign that it was that sort of a wear?
It was a sliding wear.
Yeah.
Sliding wear. Evident, and there was a combination of sliding wear, and there was even some fatigue wear in the filtergrams as well. Yeah. But yeah, an interesting point. Again, it's pretty textbook. You get told these things when you're first starting, but the oil actually picked up an indication first. You know, that was probably what triggered a little bit more investigation to start with as well. That we had so much history and data on this transmission that we were confident that when we saw changes in the oil that something was going on. And then it was just a matter of expanding what else we were looking at. What are the probabilities of failure modes occur in a transmission? So it made sense just to think through, but it's always good to see something like that because it just reminds you that you can just assume nothing's right. So yeah, it was good. Thanks, Jason.